Hello and welcome to another video of Cornerstones of Math. Today we are going to solve the following system of inequalities. The first one says 1 over x minus 2 plus 1 over x minus 2 square is less than 0. And the second one says x plus 1 over x minus 1 cube times x plus 1 over x minus 2 square times x plus 1 over x minus 3 is less than or equal to 0. Now, when we are dealing with fractional equations, we multiply the least common multiple of the denominator in order to remove the fractions. But when we are dealing with inequalities, we must be careful because this direction of the inequality sign must switch whenever the negative numbers are multiplied on both sides. But here, this x is yet undetermined, so we don't know whether either of these are positive or negative yet. Therefore, the trick here is we multiply x square x minus 2 square on both sides, which is always positive. Well, it can be 0 when x equals 0 or 2, but these are the values that make the denominator 0, so they cannot be a part of the solution. So we can claim that this term is positive without any problem. So if we multiply this, we obtain x minus 2 plus x is less than 0. So x squared minus x is less than 0. Therefore, x minus 1 is less than 0. Therefore, x is greater than 0 and less than 1. So we have this. Now, when solving the second inequality, using this range obtained from the first inequality can be helpful. The second inequality contains common terms x plus 1 over x, so let us substitute x plus 1 over x as t to simplify the given inequality. Then we have t minus 1 cube times t minus 2 squared times t minus 3 is less than or equal to 0. Now let's make a good use of this result. We know that x is positive, hence the possible range of t is limited by the relation between arithmetic mean and geometric mean. So we have 2 times square root of x times 1 over x, which is simply 2. So we have t equal to or greater than 2, and this implies that t minus 1 is positive, so this entire term is positive. So we can simplify the inequality by dividing both sides with t minus 1 cube without changing the direction of the inequality sign. Therefore, we simply have t minus 2 squared, t minus 3 less than or equal to 0. Now, this particular inequality can be solved in two ways. The first and most general way is plotting the graph of this function, which looks like this. This is quite easy if you have learned the basic properties of cubic, quartic, or higher degree polynomial functions in calculus, but I think that should be explained in detail in my future work. So for now, let's just use this graph to solve the inequality. So we have t less than or equal to 3. But we already have t greater than or equal to 2, so the common range would be this. The other method for this specific inequality is like this. Since this t minus 2 squared is always equal to or greater than 0, this inequality holds either when this t minus 2 squared equals 0, or t minus 2 squared is positive and t minus 3 is less than or equal to 0 simultaneously. This means that either t has to be 2 or t cannot be 2 and t must be less than or equal to 3. This gives the range t is less than or equal to 3, so combined with this part, we have this range. Right, so now let's switch t back into x, so we have x plus 1 over x in this range. However, this part comes directly from the arithmetic mean geometric mean inequality, which holds for all positive values of x, so we only have to deal with this part. We know that x must be positive from the solution of the first inequality, so we can multiply x on both sides and the direction of the inequality sign remains unchanged. So we have x squared plus 1 less than or equal to 3x. So x squared minus 3x plus 1 is less than or equal to 0. Therefore, x is in between 3 minus square root of 5 over 2 and 3 plus square root of 5 over 2. Now just to be clear, this is the solution to the second inequality under the conditions that x must be positive. However, the solution to the first inequality is that x must be positive and less than 1, and we haven't considered this part of the inequality when solving the second inequality, so we still have to find the common range between this and this, which is x is greater than or equal to 3 minus square root of 5 over 2 and less than 1. And this is our final answer. And that's all for this video. Thank you for watching. If you like this video, please consider giving it a like and also subscribe to my channel for more interesting math problems. And I will see you in another video.